But we'll be starting now. So welcome. Good morning, good afternoon, good evening. We're ready to start today's webinar on instrumenting 5G and IoT networks. You can't control what you can't measure. I'm Marshall England, Vice President of MantisNet, and I'll be a moderator for today's webinar. Very quickly, let's review some housekeeping items. Registrants can access a PDF of today's slides below the webinar window in the attachment section. Additionally, a link to a recording of the webinar will be sent to the email that you registered with. For questions, you can submit them using the question area of your webinar control panel, and we'll address submitted questions during the Q&A portion of the webinar. For those that we can't get to, we'll respond with an email. The webinar is listed for 60 minutes, but hopefully we can finish here within the next 40 minutes. Next, I'd like to introduce today's speakers from MantisNet. Mike Fetcher is a technical account manager with MantisNet who works with telecommunications providers and U.S. government agencies on network visibility, infrastructure, and cybersecurity solutions. Elliot Starren is the founder and CTO of MantisNet, and he has over 25 years of experience in researching and developing advanced networking, signal processing, and communication systems. I'm Marshall England, Vice President of MantisNet. I've been in the cybersecurity and software industries, helping organizations embrace digital transformation while managing cybersecurity and operational risk. I'll now turn it over to Mike for an overview of MantisNet and the technical discussion on instrumenting 5G and IoT networks.
Thank you, Marshall, and thanks, folks on the phone, especially those who were able to hang in there while we worked through some issues. But we'll go ahead and start things off here with just a quick two-slide look at MantisNet at a high level to better understand our company and the view of the world we have. From there, we'll jump right into the topic on hand, which will be instrumenting 5G networks and the technology that MantisNet offers that kind of pairs well with looking at creating visibility fabrics within a 5G environment. So to start things off looking at MantisNet, we're really about harnessing the power of data in motion as a data source for analytics. So if you think of the world of analytics out there, there's a lot of different approaches to how you actually gain insight from your networks. Most commonly pulled from logs, PCAP files, things of that nature. What we're doing here at MantisNet is we're actually harnessing the data as it transits the wires themselves, tapping into links either virtually or physically, pulling information out and being able to do so in a very intelligent way to put a bit more structure around the information for your analytic tool set. More specifically, what we do here at MantisNet is I'll break down just three core tenets of the company. The first is that we're all about being data plane programmed and P4 driven. If anybody on the line is not familiar with P4, I would suggest you check out p4.org. It's a great resource to discuss what P4 is, which is really just a programming language that allows you to do some unique things on the data plane itself. If you think of the world of SDN and NFV, there's been a lot of things that have happened over the years from a control plane standpoint. Until P4 came along, the data plane has been largely ignored. So P4 is core to everything we're going to discuss today. The second thing here for MantisNet, another core tenet of our company, is that we're truly cloud native so that we can deploy our solutions anywhere. Everything we'll discuss today it kind of keeps with this cloud native focus in mind, allows you to take our container-based solutions that can be deployed anywhere from the edge to the core. And then finally, the last point here is a bit of a differentiator in the marketplace for us, and we'll spend a bit more time at depth going into this. And it's the fact that we try to take large unstructured amounts of network information and make that information data science ready, if you will. And once again, that will become clear here in a few upcoming slides. So let's go ahead and jump into the 5G content and the discussion at hand. So what I'd like to discuss first before we get into some specifics here is looking at the 5G landscape and some of the challenges that are being put upon folks that are trying to gain visibility and maintain a solid analytic and monitoring strategy. The first being the end user speeds. This drives most conversations around 5G. It's the promise of 10 gig and being able to live in that new world of just highly increased speeds. Latency, absolutely another thing that is a bit challenging from a visibility standpoint to be able to ensure that you're gaining visibility into all of these connected devices that need to be able to communicate instantaneously. And just to go along with that is the growth of those actual connected devices. And, most importantly to the conversation in hand is, core to successful 5G strategies, whether it's true standalone or NSA, it's really looking at the core moving from an on-site physical, perhaps maybe somewhat virtualized core that exists in 4G to a completely cloud-native virtual core for on-demand scaling within 5G environments. So with this all said, when you look at environments and gaining visibility, you really need to take a new approach in two different ways. The first and foremost would be to make sure that you're addressing network performance monitoring, and the second will be threat detection and response, which we'll cover in depth. So now I'd like to take some time to talk about metadata to help achieve visibility at scale, and really the topic of today's discussion is being able to, understand that you can't control what you can't measure. So we'll discuss everything through the lens of metadata and how it can allow you to achieve visibility and to do so at scale moving forward into 5G environments. So the solution I'd like to talk about for MantisNet is what we call a PPE, or a programmable packet engine. And so what this solution is, if you take a look at the right-hand side of the screen, the graphic really gives you a high-level understanding of what the PPE does. It pulls in all that unstructured network information. It is a containerized piece of software that then takes the unstructured network data in and creates serialized metadata on the tail end. More specifically, what we're doing, and back to address one of the core tenets here at our company, is to take the network to turn it into a data science problem. So imagine having a stream of unstructured network packets going through the PPE. What the PPE is doing is creating key value pairs representative of the metadata of those packets, or tuples, to provide the analytics. Our approach for doing it this way is really to consider all of the analytic tools, approaches, and techniques that are available in the data science world today, and to understand that all of those techniques and approaches don't know how to deal with this unstructured information. So we're trying to create a bridge, if you will, from unstructured to highly structured, and to do so in a very streamlined fashion that works at line rate for real-time visibility. I'll go ahead here and present just a very quick four-step process of exactly how the PPE works, and then we'll jump into some more specifics and talk about instrumenting 5G networks. But with the PPE, the first thing is to be able to inspect network traffic, be it from a raw or filtered link coming off of a physical or virtual tap, but you need to get traffic across the PPE. In step two, this begins to start looking at the internals of the PPE. So kind of the approach we've taken here is that internal to the PPE is what we have this concept called decoders. So each decoder is responsible for looking at a single network protocol to generate metadata from that protocol. So in front of you, you can see a few of our decoders that are currently available. There's a much larger list that we'll touch on. But I decided to put up these on the screen because they're fairly horizontal. Whether it's a 5G environment or any environment, you can find out a lot about what's going on within a network, looking at DNS or HTTP, DHCP, et cetera. So step one, look at traffic. Step two, start chopping up that traffic and decoding the information based on protocols. Step three is to continuously stream that metadata into a messaging bus. So the messaging bus is kind of the integration point and the demarcation line for MantisNet. So we're pulling all of this information off in any customer environment where they have a PPE. They can determine what decoders they would like to place in there, and then they're pumping all of that information out from a continuous standpoint into the messaging bus, so that in step four, consumers can come in and pull down either synchronously for true streaming analytics or asynchronously and do things in a batch mode approach. Now, on the next slide, I'm going to take this same view we have in front of us right now and take a look at it, perhaps a more 5G specific use case. So starting at the top with the decoders themselves, if we have a PPE that is going to be deployed in networks to look at 5G traffic, it's very important to understand the different protocols that are listed there, be it NGAP, et cetera, from a control plane standpoint, or HTTP2 from a data plane standpoint as well. So it just gives you the flexibility to be able to deploy these decoders and make sense of protocols that previously weren't well known in the marketplace. The second step would be looking at how we actually communicate the metadata down through our pipeline. So we often use JSON. We can support protocol buffers, Avro, et cetera, even do some custom serialization formats if needed. And then our messaging buses, Kafka would be the most common, but we also support some cloud solutions such as Kinesis and Microsoft Event Hubs. And then analytic consumers there, just putting a variety of some of our partners in the marketplace for just a better idea of how you can be looking at the information. So before we jump into instrumenting 5G networks, I'd like to just take a quick recap of the PPE here and why it's relevant in the 5G context. The first is that we're doing everything at line rate for true packet decoding, so that, you know, essentially if you're trying to do things at 1 gig and up to 10 gig with 5G, you need to be able to pull out this information at true line rate, and you can do so with the PPE. In the middle, in-memory computing, I would say, is the biggest one for us. Everything we're doing is done in memory. We're not requiring any writing to logs or writing to disk that would create unnecessary bottlenecks in the pipeline. And then finally is just our approach from day one to be a cloud-native solution so that you can deploy these containers anywhere within a 5G environment. And finally, I know we discussed some of these protocols, but I just once again would like to reiterate the importance of control plane decoding within 5G environments and being able to look at these three separate protocols, and the fact that our PPE can natively do that moving forward is very important from a 5G context. All right, so we'll go ahead now and talk about instrumenting 5G networks. So if you think of the PPE and what it creates for users, it's really the capability to have a visibility sensor that you can deploy anywhere within a network. So you can have remote on-demand visibility. So these visibility sensors, these PPEs, are all in-memory processing engines. You can place them anywhere. You can spin them up very quickly for horizontal scaling as your demand is needed across your 5G architecture. Now, looking at the visibility sensors themselves, there's a couple of unique functions they can perform within a network in terms of extracting information. So everything we discussed around PPE metadata generation is included. You can look at different network protocols. You can generate key value pairs if there's a new protocol that you may not be able to immediately decode. You can work with our engineering team, and due to the P4-driven nature of our engineering design, we can get new protocols understood very quickly. The second capability that this sensor can provide is to generate net flow statistics directly off the line itself, so that may be very helpful for those that like to analyze information or gain a higher level picture of the network by using net flow. And then the final two here are just really pretty decent functionality within a visibility sensor if you think about wanting to take a quick pulse of any part of a link within your environment. The first would be the regex functionality of the sensor. So you can, switch this sensor from generating metadata and say, I want to start, using the regex functionality, which will allow you to just do thousands of regex searches simultaneously. So if you want to really start diving into the payload a bit more, you can do so. And then finally, entropy is just very straightforward. It gives you a score of 1 or 0, 1 being encrypted, 0 being unencrypted. So if you wanted to check a quick pulse anywhere in the network to say, I'm pretty sure my data is encrypted here, you can go ahead and do so, and vice versa for unencrypted links. And this is helpful for those that would like to know if their data in flight is encrypted, perhaps due to compliance regulations and things of that nature. So now that we kind of understand the different capabilities that are inherent to these visibility sensors, let's look at how they're deployed out into the network, starting by looking at what was before, if you will, the world of 4G. So within 4G monitoring fabrics, it really does rely on having physical access to different systems within the core and to be able to pull that information down into an appliance-based packet broker. If you think of the world of 5G and the evolution of the core from physical to virtual and having multiple edge networks and co-locating compute resources at new radio base stations, this type of approach does not scale well to be able to give you true visibility and push out towards the edge as you're seeing within 5G environments. So looking at 5G and now having these visibility sensors, you can place them anywhere from the core to the edge due to the fact that they're very lightweight containers. You can spin them up quickly if your actual physical infrastructure is spinning up quickly to support the demand from customers, and allows you to just really streamline the process of analytics by using Kafka as an integration layer. You can pull in information to a custom analytic pipeline. You can look at the information using batch mode-based solutions, true streaming analytic solutions, or even just send it to storage targets for forensic inspection. So it's just a lightweight, efficient way to evolve with the new infrastructure found in 5G and to be able to put sensors out anywhere that are container-based and can sit on a variety of different pieces of hardware. All right, and then finally here on the visibility sensors roadmap I'd like to discuss is some of the features we're currently adding and looking to add in the future. So the grayed out blocks, if you will, that you see on top there. That's what we've discussed as far as currently available. On the bottom are our roadmap options. So the first functionality that we're looking at is to be able to do just essentially TCP dump capability or PCAP to be able to capture the packets themselves, to do a deep dive into the information if you have a troublesome link or would like to look at different aspects of what's going on between points A and B. The second is just a very quick pulse check on the performance of any area to get statistics such as bandwidth, jitter, and latency details. Our correlation or CORR capability is interesting. It's the ability to correlate and map things from, a user ID, if you will, to actual network events as they're occurring. So this is very helpful in a cyber context. And then finally, we'd be looking at network packet injection or network performance monitoring injection. So to be able to inject packets into the stream to better understand how quickly that packet's moving through and to gain a very thorough understanding of the actual performance. So finally here, I'd like to talk about, taking a look back at metadata and why would you want to consider metadata as, a source of analytics in the world of 5G? And a lot of that has to do with the savings you're gaining from, alternate options such as looking at PCAPs or log-based approaches. So what we're going to put up here is just a quick look at some testing that we have done that shows the compression savings you're getting for specifically GTP traffic by looking at metadata. So for this test, what we've done is we've taken a PCAP file that's representative of 23,000 actual PDP context messages within GTP traffic, and we're putting it through our PPE, which just has a GTP decoder on it. And as I mentioned before, we support a variety of different serialization techniques, so we decided to get two just to see if there's any difference in savings based on the serialization technique, and pump this through Kafka to get a better understanding of the size of the PCAP versus using the metadata to be the source of analytics, if you will. So we saw from the results that, there's a fairly significant savings in terms of overall amount of information that needs to be stored and analyzed. So if you're moving from the raw packets to JSON metadata, for example, you see you have a 50% size reduction, and looking with the message impact serialization technique, we're looking at 56% savings. So this is I'd like to reiterate, very important when you're looking at the world of 5G and the, exponentially increasing amount of information, speed of information, demands on latency. To be able to exist in that world and move forward, looking at PCAPs or looking at logs retrospectively are not going to scale well. Having a lightweight solution such as a PPE that can be deployed anywhere and also provides a significant amount in savings from the size reduction is very helpful. And then finally, just to recap things here a bit, looking across the board here for the new demands of 5G, we've discussed the changes and demands for bandwidth and latency, moving from a finite set of protocols and system configurations to new architectures and protocols as listed there in parentheses, moving from millions of devices to billions of connected devices. And the biggest one is the evolution of the core, going from the physical core to a virtualized core for on-demand scaling. And with MantisNet, just as a reminder here to have up on the screen, some of the key takeaways from this discussion is to be able to create end-to-end visibility, is either physical or virtual, to provide new forms of that deep visibility based on metadata to look at any point from the core to the edge at speed and scale, and just to evolve with the bandwidth and latency demands. This is really the new approaches that are needed for performance monitoring and threat detection. You need to be able to do so at speed, and to be able to do so by leveraging a cloud-native solution. And then finally, this is really just about helping to gain deeper visibility and control of network traffic, just to really focus on increasing the end-user experience. And with that said, we'll go ahead and move things over to the Q&A portion of this. And we do have Elliot Starin, who's the CTO and co-founder of MantisNet, on the line, who is happy to address any questions you may have.
Yeah, thanks, Mike, for the great presentation on instrumenting 5G and IoT networks. Again, if anybody has questions, go ahead and put them into the question section of your webinar console. We did have one question that came in related to, can you describe more of the benefits of using this solution as compared to the packet brokers and dedicated monitoring fabrics? Is using virtual software sensors simpler and faster?
Mike, do you want to take that, or?
No, you can go for it, Elliot.
Okay, so the main real leverage you get is essentially the cloud native leverage. So because everything is being containerized and virtualized, you have the opportunity to sort of spread these out and allow them to scale in ways that you could never allow otherwise. So it's very, very flexible. And much more importantly, the information that you're actually trying to capture is sitting between containers, that are actually virtualized networks inside of a single computer. So you actually don't have access to them via packet broker or on the wire anymore, right? So if somebody spins up a whole variety of containers on a single platform or on multiple platforms, you essentially have no insight or visibility into that space without actually having a sensor that can actually reach in and look at different namespaces, network namespaces and/or virtualized interfaces. So it's actually not only helpful, but in some cases it's actually required.
Okay. Another question that came in was somebody currently has a lot of 10 gig network infrastructure. How can they accommodate faster speeds as they explore moving up to 25 or 40? And then for those that may be operating at higher speeds, like 100.
The higher data rate feeds, if we're talking about wireline feeds, require hardware, and there's really no getting around that. Even if you want to try and load balance it, you're still trying to, if you're trying to deal with it as a software problem, you're probably going to need a load balancer at the higher data rates just to send it out in a format and in a size that's actually consumable by downstream software analytics. So hardware at the higher data rates almost becomes a requirement as well. At the 100 gig rates, we actually have a product where we actually do load balancing and actually feed PPEs like Mike has described in that very way. But load balancing is a huge requirement and necessary, frankly, at the higher data rates.
Okay, and then can this information, I think Mike touched on it a bit, the question was, can this information be integrated with third-party analytics?
Yeah, so that's where we shine. There's nothing proprietary about anything we're doing, and we're designed from scratch, from the outset, to essentially interface to existing analytic interfaces and workflows. So Kafka as a message bus obviously is very powerful, supporting synchronous and asynchronous type of activities. Because we can be handled as JSON. JSON is consumed by nearly any analytic that exists, and obviously simply converts to other formats straightforwardly for anything else that might be used. We work with a variety of analytic companies that actually ingest our data natively with no further requirements.
And then I had a question on recommendations for best software for monitoring network traffic.
That's a loaded question there. I guess I'd have to know a little bit more about the monitoring requirement itself. We certainly support, capturing the kinds of things that Mike described, right? We look at performance. We look for things related to specific protocols, right? In our metadata publishing, we handle connection information with NetFlow/IPFix types of things. We capture a variety of different types of information on the network using these approaches, but all of them are, directly consumable by follow-on analytics. And, it might be helpful to just state perhaps the obvious here, that we're really eager to explore the challenge that people have in business associated with the time to value proposition, right? Because we're in-memory engines, we're doing all of this at real time. And if you have the ability to consume that data, as it were, like drinking water from a fire hydrant, then you get the full benefit of that. You can still write this information to disk. You could push it into an S3 bucket. You could write it to file if you wanted to and look at it after the fact, sort of forensically. But if you have an architectural pipeline that supports actually decisioning, real-time decisioning on that data as it comes past you on the wire, you have a keen sort of leverage point, at least in the world today that we live in.
Okay. Well, that looks like all the questions that we have now, but again, if anybody has any questions, feel free to contact us at mantisnet.com. For now, I want to thank you, Mike and Elliot, for your time in attending, and then everybody else, thanks for your time and watching. Thanks, and have a great day.